Software. It's called soft because it is flexible to change. However, not all changes are created equal. How changes are implemented in a software system can affect the long term maintainability of that system. The open closed principle states that the behaviors of a system should be extended without having to modify the existing system. That is, it is open for extension but closed for modification. In simpler terms, new features should be implemented by writing new code, not by modifying existing code. This reduces the risk of breaking the existing code when new behaviors are added to a software system. This also promotes backwards compatibility. Imagine you're using a library in your app and you update it to its latest version. Suddenly, the app does not work. Chances are they either renamed the class you were using, changed the input parameters, moved it to a different module, or removed it completely. This introduces breaking changes because it breaks something that was working on an earlier version. Not only that, but no one likes working on a code base where one small change requires a cascade of changes in all of the classes that the piece of code was a dependency of. Consider you provide a document storage service and you store the documents on either Google Cloud Storage or Amazon S3. For implementing this, we can create a storage class that handles uploading and downloading these files to and from the storage services. We pass the file along with the storage parameters to the upload function. Depending on the storage type passed in the parameters, we will call the appropriate internal function to upload to either S3 or Google Storage. Now, consider we want to add our own SFTP server as a storage option as well. To add this new storage, we need to modify the storage type enum to add another type of storage, the storage params data class to include the relevant information to upload to the SFTP server, and the storage class to handle the new storage type. This software design requires us to modify the existing code to extend the behavior of the software system. Every time a new storage type is added, storage, storage type, and storage params classes are modified. To follow the open close principle, we should have a storage interface with upload and download functions. Each storage type can now implement this interface and have its own parameters and its own implementation of the upload and download functions. Now, in the application, instead of calling the same function with different parameters for each storage type, we can call the same function on different objects implementing the same interface. And instead of adding a conditional block for creating the appropriate storage object, we can delegate that task to a factory class. In theory, we can foresee all the future changes required and plan our code in a way that we follow the open closed principle throughout the whole lifetime of the software system. In reality, however, we cannot predict all the changes we will need down the line. We could spend days anticipating all possible situations and planning for it. But what if those situations never occur? All that effort will be wasted, and we have added unnecessary complexity to our system. There's always a trade off between following the principle to 100% and keeping it simple. Again, these principles are guidelines, not rules.